Hey guys, so today we're going to talk about net ionic equations, and these are important because so many reactions happen in water. That's what these net ionic equations are about. Reactions are in water. Because our world is made up of about 70% water, and also our bodies, about 70% or so, 65%, so many reactions occur in water. So we need to learn a little bit how to write these equations. Okay, so here's an example. We have some iron chloride, and we're going to mix this with some potassium hydroxide. Notice how both of these are aqueous. They're aqueous solutions, meaning the salts, these are salts, metal, non-metal compounds, are dissolved in water. So imagine if we take a beaker of this solution, take a beaker of this solution, and we pour them together, we're going to end up making iron 3 hydroxide as a solid. It's going to precipitate out into a solid form and separate from the liquid part, and the rest of the solution will be made of potassium chloride ions floating around. So here's how we write these net ionic equations. First of all, what we have to do is we have to separate all the ions in everything that's aqueous. So we're going to separate the irons from the chloride. So we're going to do this. Iron, this is a +3, plus chlorine -1. All right, I'm splitting up the metal from the non-metal. If there's a subscript here, don't write those down. We don't need those. We're only going to write one ion of each atom. All right, so don't write these subscripts. Only if they're inside the parentheses for the polyatomics do we keep them. Otherwise, don't. We're just writing one element of each. This iron is a +3. It's a transition metal, and if you don't remember how to do charges from transition metals, you need to go back to the last lesson. But basically, we have 3 chlorines. They're each -1, so that's a total of -3. So this one iron has to be a +3. Okay, let's keep going. Let's split up everything that's AQ. So this K, potassiums are +1. OHs are polyatomic. Look on your polyatomic chart. Those are -1. All right. We're going to keep the solids the way they are. Just write them exactly how they are above. We're not making any changes to the solid. And we're going to split up this KCl because it's AQ. We're going to split it into its ions. All right, so this first step, just take everything that's AQ and split up into their ions. Anything that's a solid, leave alone and bring down, because this is what's happening. If we have a beaker full of all this stuff here, we're going to have all these ions floating around. What's going to happen, these guys here are going to come together, the iron's going to join with the OH, and we're going to get our solid, and then the K and the Cl are just going to be floating around also. We may have some of this other stuff floating around too, but we'll get to that in a different chapter. All right, so now what we have to do is get rid of our spectator ions, everything that's the same on both sides of the arrow, because they are not participating in the reaction. This K+1 and this K+1, they're not doing anything. They're not used to form this iron 3 hydroxide. So we're getting rid of our spectators. What else? This chlorine -1, get rid of it with this chlorine -1 on this side, and that's it. Those are the only ones that are the same on the both sides of the arrow. All right, so finally all we have to do is just bring down what's left. We have this iron +3. We have this hydroxide, -1. Keep the charges in there. Okay, and then finally we have our solid iron 3 hydroxide. There we go. This is our net ionic equation. It's kind of like a bottom line equation. When all this stuff is reacting up here, really the only thing that matters is that this iron's binding with the hydroxide to give this iron 3 hydroxide. So the last step here is we have to balance. Notice we have 3 OHs, so we have to go here with a 3. We balance just like we did before. And this iron has one iron, there we go. So there's actually 2 things we have to balance. One is the atoms, which we just did, and also now you have to make sure the charges are balanced. The charges have to be the same on both sides of the arrow. So solids have a charge of 0. Remember, There's no overall charge, so it's a 0. So on this side, the charge is 0 because it's a solid. And this side, we have a positive 3 from the 1 iron. And then we have 3 negative 1 OHs, which is negative 3. So this equals 0. So these are the same. Your charges are the same. So we're done. This is our balanced net ionic equation. And usually when you balance the atoms, the charges will balance also, but it's just a final check you should do. All right, let's take a look at another problem. Here we have some silver nitrate and sodium chloride, both AQ. They're both aqueous, means they're both dissolved in water. And we mix these up in a beaker, and you're going to get some sodium nitrate that's aqueous, but then we're going to get a solid silver chloride. We're going to get this as precipitate in the bottom of our beaker. All right, so let's see. We have to split up everything that's aqueous into their ions. This silver is a +1. Nitrates are a -1. Look on your formula sheet. Sodiums are +1 because they're in group 1. Chlorines are -1 because they're in group 17. We're going to split up this sodium nitrate here because it's aqueous. And we're going to leave the silver chloride just the way it is because it's a solid. This is not broken up when it dissolves in water because it doesn't dissolve in water, which is why it remains a solid. It's insoluble. It does not dissolve in water. That's how you get solids. All right, we split up all our AQ ions. We left our solid alone. Okay, let's get rid of our spectators. We have an NO3 -1 here. NO3 -1 there, get rid of it. We have sodium +1 here, sodium +1 there, get rid of it. That's it. Okay, next step, everything else gets brought down. We have our silver +1, keep the charges on there, because remember, these are in water, and that's what happens when they're in water. They're ions floating around. And we'll keep our silver chloride intact because it's a solid. Let's balance, 1 silver, 1 silver, 1 chlorine, we're good. Notice the charges, solids have a charge of 0, +1 -1 is 0, we're done. This is our net ionic equation. All right, again, it's a bottom line equation. You put all this stuff in a beaker, and really this is all that's going to happen. All these spectators are just floating around, not doing anything inside our beaker. Let's go on to the next example. So this one's going to be a single. The last two that we did were doubles, if you noticed. 2 and 2, metal, nonmetal, metal, nonmetal. These were doubles. These are also doubles. The NO3 acts as our nonmetal. But now we're going to a single. We have a piece of lead, a solid piece of lead. We're going to mix it in with some silver nitrate, which is AQ. And what's then going to end up happening is the lead's going to come in, kick out the silver. So now the silver is going to be alone, and the lead's going to hook up with the NO3. So in this case, we have 2 solids and 2 AQs. All right, that's okay. We can do this. Don't let it throw you. We're going to do the same thing as we just did. So let's bring down, first let's separate all our AQs. So this lead is a solid, so we're going to leave it alone. We're going to split up this AQ. Silver is +1, NO3 is -1. And we have another solid. So the silver is going to end up being a solid, so we're going to leave it alone. And we're going to split up this lead nitrate. Now, what's the charge on this lead? I want to make it a +2 lead. So I'm going to go back up here. The lead's a +2, crosses over, crisscrosses over. The nitrate's -1. So we'll make that a +2. Again, this will be given to you on a test. This whole entire first equation will be given to you. There's nothing you really have to do there. And then we're going to split up the NO3 from the lead at -1. Okay, so let's get rid of our spectators. Now, remember, they have to be exactly the same elements, the same charges. So we have the NO3 -1, get rid of it. Let's look at this lead. This is a lead solid. Solids have no charges. I'll just put a little 0 up here to remind you. and we have a silver plus 1. So over here we have a lead plus 2. So this lead plus 2 is not the same as a lead 0. And same thing with the silver. The silver plus 1 is not the same as a silver 0 because this is a solid also. So let's just write our net ionic equation, bring down what's left. We have our Pb, we have our silver with a plus 1, and we're going to make some silver solid, and we're going to have a lead ion. All right, so this is kind of a different looking reaction. This is actually something we may talk about at the end of the year. These are called oxidation reduction reactions, where elements are just transferring electrons around. You can see this lead went from a 0 charge to a plus 2. Okay, it gave away a couple of electrons in the process. The silver was a plus 1, it went to 0, so it ended up gaining an electron to be neutral. That's okay. So this is our net ionic equation, but let's balance. One silver, one lead, one lead. Okay, we're good, except for the charges. This is why I want to show you this example. The charges do not balance. Remember, solids are charges 0. So this side of the arrow, we have a plus 1, just from the silver. On this side of the arrow, we have a plus 2 from the lead. We have to balance these. They have to be the same. Not necessarily 0, just the same. So in order to balance these out, we have to get to a plus 2 charge on both sides. So we're just going to put a 2 in front of the silver. So now we have 2 positive 1s, which is a positive 2 on this side total, because this is 0. And then over here we have the plus 2 from the lead. So these are the same charge. That means they're balanced. But let's go back here. We have 2 silvers here, but we need 2 silvers here, because our atoms have to balance, and so do our charges. But putting the 2 on something that doesn't have a charge doesn't affect this charge. This side is still positive 2. This side is positive 2. We're done. This is our net ionic equation, balanced and ready to go. Piece of cake.